Good morning, students. Up to last lecture, we have to see that is the current electricity. Okay, how the electric current is flow through an electric circuit. Okay, so up to now we have studied that free electrons are most responsible for the motion of charges. Okay, so as we apply potential difference between any electric conductor at that time, due to that potential difference, what happen, negatively charged free electrons are moved toward the positive terminal of a that particular battery or potential different device. Okay, so suppose this is a one electric wire. Okay, this is a conductor. Now at the room temperature, this is EB wire. Okay, so now if we measure whether the electric current is passed through this wire or not. Okay, so initially we will find that if we not connect any potential difference, okay, or cell or battery, so automatically current will not be found in this wire. Okay, so simply that we see that most free electrons are in motion, but they are in random motion. Due to that, their average velocity in particular direction is always zero. Okay, but here suppose we connect a one potential difference. Okay, suppose we connect here one battery. Okay, now what happens if you connect one ammeter here to check whether the electric current is passing through the circuit or not? At that time, what happen? Okay, so we will see that as we connect the battery or circuit here, potential difference, battery means what? Simply potential different device. Okay, it make potential difference in between terminal A and 2. Okay, this is the higher electric potential we connect to the terminal A, and lower electric potential we connect to the point B. Okay, so such a way that due to this device, what happen, the potential difference is generated in between terminal A and B. Okay, so as we connect this battery in between wire AB, at that time what happen, current will be start to flow, and that will be flow in this direction. Okay, because all the negative charge electron present here, they move toward the positive terminal of a battery. Okay, so how much electric current will be flow from this wire AB? Okay, that depends on the potential difference that we measure. We call it volt. Okay, potential difference has unit volt, and we denote it by sine phi. Okay, so how much current will be flow through this wire AB, that depend on this potential difference. Okay, so the scientist Simon Ohm, okay, that study the relation between electric current and potential difference. The relation between current, that is I, and potential difference is studied by the scientist Simon Ohm. Okay, and he studied that. After his study, he made one conclusion, and that conclusion is that whatever the electric current is passing through the electric conductor, okay, that directly proportional to this potential difference. Okay, so according to that statement, okay, what Simon Ohm studied one case, that he studied the current passing through an electric conductor is directly proportional to the potential difference across it. Okay, so V is the potential difference that we apply across this wire AB. Okay, AB is a conducting wire across which we connect this battery. Okay, so here according to Ohm, whatever the current passing through wire AB, that depend or directly proportional to the potential difference across it. Okay, so this is a direct relation between current and V, that is the potential difference. Okay, so current passing through any electric circuit is directly proportional to potential difference. Okay, direct relation. Direct means what? If we increase potential difference, then current will be increased. So this relation is called as a direct relation. If one term is increased, then another term will be automatically increased. So that is why such relation are called as a direct relation. So, so this current passing through electric conductor is depend on the potential difference. So we can say that this I, that is the current passing through electric circuit, is proportional to the V, that is the potential difference across the terminals of a conductor. Okay, so we have to move this proportionality constant. So we have to find out somewhat prompt relation between these two terms. Okay, so that is why we remove this proportionality constant. So this I will be equal to K into V, where K is somewhat constant. Okay, K is what? Constant. So this K will be equal to constant. So now this K is in multiplication. Okay, if we send this K to the left hand side of the equation, okay, now it is in right hand side in multiplication. If you move this K into the right hand side, so it will become in dividation. So I into 1 by K, so it is in dividation term now. Okay, it is multiplication, here it will be came in dividation part. Okay, so I into 1 by K will be equal to V. Okay, so here I into R, so this 1 by K we call R. Okay, and this R is nothing but the resistance of that particular electric conductor. What? 1 by K is nothing but the resistance. So we can say that I into R will be equal to V, that is the potential difference. Okay, so we can say that V is equal to IR. Okay, V is equal to IR, or we can say that this R will be equal to V by I. Okay, here multiplication, R in multiplication, if you move this term to the left hand side, then it will become a dividation part. So our R will be equal to V by I. Okay, so here first of all Simon Ohm studied one case that he find the electric current passing through an electric circuit is directly proportional to potential difference between the electric conductor. Okay, so we can say this current I is proportional to potential difference, that is the V. So we remove this proportionality constant, we have to some prompt relation between these two terms. So we introduce one constant here K. Okay, so I will be equal to K into V. Okay, we move this K into the left hand side of the equation, so it will be divided. So I into 1 by K will be equal to V. So this 1 by K is called R, that is the resistance. What? R is what? Resistance of that particular electric conductor. Okay, so this R is the resistance of a circuit. So we can say that R into 1 by K, that is R will be equal to V. Okay, so we can say that V is equal to IR, or R is equal to V by I. This is the Ohm's law. Okay, and statement of Ohm's law is the electric current passing through an electric circuit. Okay, what? Electric current is a passing through the electric circuit is directly proportional to the potential difference across the electric conductor or that particular circuit. Okay, so current in particular conductor is proportional to potential difference. As potential difference increases, current passing through it also increases. As potential difference decreases, current passing through that circuit is also decreases. Okay, so that is the direct relation. If one term is increased, then another term will be increased. If one term decrease, another term will be again decreased. So so such relations are called as a direct relation. Okay, so this is called as a directly proportional to V. I is directly proportional to V. So the current passing through an electric circuit is directly proportional to potential difference across it. Okay, so that is the statement of Ohm's law, and this is called as a Ohm's law. V is equal to IR, or R is equal to V by I. Okay, so you are understood this concept. Okay, so remember all that thing. Now we have to see next topic. So the next topic we have to see, that is the unit of resistance. Okay, so simply we have to remember that unit of resistance has name ohm. What? Ohm. And this is the sign of resistance. This is headphone like structure. Okay, so this is a unit of resistance. It's called as a ohm, and it denoted by this sign. Okay, that part we have to also remember. These units are important because we have to use it in problem solving part. Okay, so this is the ohm, and this is the notation of this unit. Okay, so we know this is formula. Okay, this is Ohm's law, that is the V is equal to IR, or we can write this R is equal to V by I. Okay. Okay, so R is what? Resistance. Okay, so 1 ohm resistance is equal to how much? That we have to find out. Okay, so formula of resistance is equal to R is equal to V by R. We know V is nothing but the potential difference. Okay, that measure in volt. Okay, potential difference is measured in volt, and I is the electric current that measure in sign that measure in ampere. What? Ampere. Okay, that is the unit of electric current. So so here by using this formula we can say that 1 ohm resistance will be equal to what? 1 volt potential difference divided by 1 ampere current. Okay, that is the formula of 1 ohm resistance. What? 1 ohm resistance. Okay, if 1 volt potential difference is applied across an electric conductor, then 1 ampere electricity is passing through that circuit, then whatever the resistance that current feel, that is nothing but the 1 ohm resistance. Okay, so here you have to remember only one thing, that unit of resistance is ohm, and 1 ohm is nothing but the 1 volt divided by 1 ampere. Okay, so whatever the resistance filled by an 1 ampere current, when 1 volt potential difference is applied across electric conductor. Okay, so this is nothing but the 1 ohm resistance. Now next part we have to see, that is actually what is resistance. Okay, so we have studied the concept of what? Free electron. For that we consider such a wire. Okay, and we say large number of electrons are present there. Okay, such a large number of free electrons. We only show here free electrons. Okay, so these all electrons are moved in random motion, but as we connect potential difference, okay, so what happen? All that electrons are moved in this direction, okay, towards positive terminal of a battery. Okay, towards higher electric potential. Electrons are at the lower electric potential, they make their transition towards the higher electric potential, that is the positive terminal of the battery. Okay, so such a way that motion of electron is takes place. But now throughout the motion, what happen? Large number of atoms are present in this wire. Okay, I show only here free electrons. Okay, but what happen? Large number of free electrons are there, ions of that atoms are there, and these electrons also are there. What happen? So when they are moved, at that time what happen? The collision of this electron is takes place. Okay, what happen? Collision of this free electron takes place with atoms, ions. Okay, or within the electrons also. Okay, so due to that what happen? the path of their motion is goes deflecting. Okay, so suppose this is the one atom is present here. Actually electron is very small than atom, but I show here for your understanding. Due to the collision of this electron with this atom, what happens? Its path goes on deflecting. Okay, so simply resistance. Resist means what? What is the meaning of word resist? Resist means what? To oppose. Okay, so here in term resistance we understood that one case. Here somewhat oppose takes place to the motion of these electrons when they are moving. Okay, when these electrons are moving, at that time what happen? Opposed to this motion of electrons takes place due to the presence of atoms, ions in the path of the motion of electron. What happen? When electrons are in motion, at that time their collision takes place in between the atoms and ions present inside this conductor. Okay, due to that what happen? The path of that particular electrons goes on deflecting. The word hinderness is used here in your book. Okay, hinderness, HINDERENCE, hinderness. Okay, so due to that what happen? Path of that electron goes changing. Okay, actually they want to move in this direction toward positive terminal of battery, but what happen? Due to the presence of that particular atoms and ions, collision between electrons and that particular atoms and ions takes place here. Due to that their path goes changing, or simply they get deflect from their original path. Okay, due to that what happen? So actually resistance to these electrons takes place here inside the conductor. Okay, resistance takes place inside this conductor to the motion of this electron. Due to that what happen? All electrons are not moved toward this positive terminal of battery. Path of some electron goes on deflecting due to this collision between these free electrons with atoms and ions that are present inside the conductor. Okay, so here we can say that resistance to the motion of that electron takes place inside an electric conductor. Okay, what happen? Resistance to motion of that electrons takes place in the inside this electric conductor. Okay, so that concept is simply called as a resistance. Okay, and that is the next topic. We have to see resistance and resistivity of electric conductor. Okay, so simply the oppose to the motion of charges. We can define resistance is how simply the oppose to the motion of electric charges is simply called as a resistance of particular material. Okay, so this actually the conductivity is depend on resistivity. Okay, if resistivity is very high, okay, suppose this material has very high resistivity. Okay, so all the electrons will move in a random way. Okay, their collision takes place with the atom and ions. So if we measure at that case when the resistivity is very high, so they are not able to move on this path. Okay, if you connect very high potential differences here, then also what happen? They will not able to move this resistance which are present over here inside that particular conductor material. Okay, so what happen? Due to that, on the basis of resistivity, materials are divided into three parts according to electrical conductivity. Some are good conductor, some are semiconductors, and some are bad conductors. Okay, so according to how much resistance present inside that material, on that basis substances are divided into three parts: conductors, semiconductors, and bad conductors of electricity. Okay, so this resistance is an important concept or topic that defines whether the substances are conductor, semiconductor, or bad conductors, okay, of electricity, because they are directly responsible for the motion of these free charges. If this resistance is very high, as like a wood, if we place here one wood and connect these two wires to the wood, so if you measure any high voltage here, then also electric current will not pass through it. Okay, so whatever the electron present inside that wood that have very high resistance, they are not able to overcome that resistance. Due to that, some substances are what, electrically bad conductors. Okay, so now in the next, that is about the resistance. Simply resistance is what, opposed to the motion of charges. That is the property of material that opposes the motion of charges, that is simply called as a resistance. And such a case we see inside the material. Due to that, what happened? Due to the presence of ions and atoms, okay, collision of the electron is takes place with the atoms and ion which are present inside the material. Okay, due to that, what happened? Hinderness is takes place in the direction of their motion. They will move randomly after collision. Okay, so such a property is simply called as a resistance of particular material. Okay, so that much part up to resistance we are see in today's lecture. Now from tomorrow we have to see what is resistivity. Okay, resistance and resistivity, there are two different concepts. That how they are different, that we have to see in tomorrow's lecture. But up to now we have studied the Ohm's law, that is V is equal to IR, and second, that is the resistance, that is nothing but the R. Okay, that denote by the letter R, resistance, which denote by sign Ohm. Unit of resistance is Ohm. Okay, and resistance is denoted by the letter R. Okay, that much part today you have to remember. Remaining part we will see in the tomorrow's lecture. Thank you.